Okay, so I separated things into 1,000 piles. Thank you for giving me all the work. It's helpful for me.
Yeah.
One of the things we're gonna do this year is like, and this is something I got from my sister's school, is like track pre and post. So we would always like last year look at like how kids did the first time, but we never went back and revisited, okay, those kids are in the bubble, did they actually do better? So that's something I wanna do this year. And so for math, I wanna see all of them, but I did not name that yesterday. But
Okay.
it's a new project. I'm gonna make a little Excel sheet after you leave me, and they'll track our bubble kids. But first, I'm gonna talk about the first piles I sorted into. I looked back at the objectives, and Monday's lesson is about like using the properties, and Wednesday's objective is about justifying, like when you solve it, like actually applying and saying what they are.
Mm-hmm. So Monday was just solve.
Solve, and so I separated them into two piles. I separated them into all the kiddos who got the wrong answer.
Mm-hmm.
And at first, I usually do 100, 67, 33, and that's what I did, but then I started to notice a trend. So I separated it into all the kids who just got the answer wrong, and all the kids who got the answer right, but got the incorrect properties.
And you're looking at number 2, right?
Mm-hmm.
Yeah, me too. Like number 1 was like...
They did pretty well in that, and that's directly aligned to question...
One of them, I don't remember the number. 7? No.
14 on the test. Anyways, I looked at number 2. So all of these kiddos got the answer wrong, just straight up wrong. But all of these kids here got the answer correct. They said the incorrect properties. So for me, this is a flaw in the exit ticket design. Like the property should have been saved for Wednesday. That's the design.
Wait, oh, you mean today?
For Wednesday's lesson is when they're actually supposed to justify and say, like, this is right because of the distributive property. This is right because the inverse operation, particularly the additive. But Monday's objective on the AP for All grid is actually just using them. So here says use it, and here says reason about the solution process through explaining it in terms of mathematical properties. So they didn't actually have to explain it yet, is my understanding.
Oh.
Because this is solving,
Yeah,
and this is
so
justifying, and you
I
have
would
them
have said
solve and
that,
justify.
now I understand what you're saying. Solving is what we did, that's what we did on that, like, added day of, like, lots of inverse operations, if that makes sense. This day is added because this justify is what I'm doing today. This one has lesson 2.6. The X ticket has variables on both sides.
Mm-hmm.
So I split that day to be a day where the variable's on one side, which is what you're seeing, and then today, which is where the variable's on both sides. So the idea would have been, I think this is in the quarterly plan, that this should be aligned to like building to that 2.6 where the variables are on both sides. If that sounds right. Is that what it says or no?
It says solving linear equations. And then you have a day added tomorrow. And you had a day added before this. To solve linear equations.
Okay, so if we're looking at to 5, so you're saying we just want them to solve.
Right. We weren't ready for this justification yet.
Okay.
And so, I don't think it's fair to put this in the grade book. Did you put this in the grade book? Okay, good. But if you're just looking at solving, which is the objective, then all these kiddos actually got it right.
That's cool.
And so, in looking at that, like that, if you just look at solving for, solving the equation, which is the objective, like this is 50% of kids.
That's great.
And so that increased mastery, which is much higher than I think, what was it?
38.
38%. Like this is at least 50% of the kids. So let's just focus on number 2 and let's focus on solving. So if you look at these kiddos, basically the steps they have to take is they have to distribute, they have to combine like terms, they have to do inverse operations, and minus their algebra when they do so. So in these kiddos, wait, JK, we have to look at the exemplar first, my bad. I'm sorry, Steven, I'm rusty. Alright, so talk me through the steps you took in your exemplar to solve.
So I distributed combined like terms, identifying that 14 and 0.8 are like terms. I actually added this part, I don't know why I didn't do that on the exemplar. It's important to separate it because you might try to combine like terms across. Then distribute combine like terms and use the inverse operation to subtract 14.8 and divide by -7.
Perfect. And if you look at Xavier's, it was so awesome to pull Xavier as an exemplar. That made my heart so happy. But look at Xavier's. How did Xavier's match yours? And then what did Xavier have in yours that you didn't?
Yeah, Xavier's is great. The one thing that I worry about with Xavier's is he showed work of dividing by 7 instead of dividing by -7.
Yeah, lucky there.
And I think he typed in his calculator, he knew he was dividing by a negative, but like that's not what his work says.
But he also matched your model perfectly by putting that line through the middle, and students that did that, I did notice they organized their workspace much more neatly.
Yeah, I think the organization of the work is actually a thing I didn't stress as heavily as I could have, because students who are organized tend to not make small mistakes like losing negatives.
Right, and that's why I pushed you to have more white space last week.
Is that it?
No, and you are giving kids more white space. So I'm noticing kids are organizing their work better. That's a strength I saw in the work. They're organizing their work better than they did last time. Okay, so with this exemplar in mind, what is the gap that you see in this work?
Okay, so they incorrectly combined like terms and incorrectly did inverse operations.
So what's the first thing they did wrong?
The combining like terms.
Okay, next one.
And this one inverse operations too. So then here, Taylor, come on. He came up to me after class and goes, I added the like terms wrong. Added like terms wrong. Totally forgot about this term. Needed to combine like terms, didn't. So is this my pile of combining like terms work going wrong? Combine like terms across the equal sign. Do that. Incorrectly combined like terms by calling that, like sometimes they do things that are like, this is positive and they wrote minus. And you're like, why did that happen? So this one, they actually didn't combine like terms wrong. They did that correctly, but for some reason changed this plus sign to a minus sign.
So that could almost go my arithmetic pile, which is my next.
Yeah, combine like terms wrong. It looks like they added all 3 of these. They did, and they made that positive. Interesting. Combine like terms, yeah, combine like terms.
And if you can't combine like, I mean, you get the idea. If you can't combine like terms, are you ever gonna be able to do inverse operations?
I wish I could show kids, I wish there was a way to like give them this stack of work and be like, the same thing, like what did they do wrong? And they were just like, they didn't add 14 and 0.8.
So, to reteach this guided practice, guided discourse or model.
Well, if mastery is 50% on solving, I think we could probably do discourse.
I would say model. My cutoff is 50. Usually, and so since we're right at 50, and that's estimated by the thickness of a pile, I would say we should model. Just in case, just because they have to solve for these equations like 3/4 of their test.
Yeah, it's huge. It's a huge standard.
So, and looking at this problem on your exit ticket and the model problem you did yesterday, I wrote it on here, so the answer's on here. What's the difference?
The fractions?
They don't have to work it with a negative in your model problem, and they don't have to work with a decimal.
Okay.
Small little thing that made a big difference here, because I think had some of the higher students that are in my arithmetic pile here, like the Angels or the Irenes or the Markells, seeing that arithmetic of working with a negative, of working with a decimal, like these were all arithmetic things. Every single one of these.
So like saying like 24 minus 5x or something there. Yeah.
And even though that's like a previous skill they should have, like making sure you're embedding that in your model, like as a refresher, because every single one of these kiddos, straight up arithmetic.
Okay.
All right, so for tomorrow, here's what I'm thinking. Cut the properties. They don't actually have to do that on the test, unless I'm wrong. I went through the whole test again. They don't anymore have to justify using the properties.
That's true. I mean, so here's
I understand
here's
what we're doing
like,
and we're pushing for mathematical language, but at this point, given mastery, I say cut it.
and you want to go get the process right before we start justifying.
Because they have to do it for 3/4 of their test. I think that's the highest leverage thing to do.
Yeah, they need to be able to do this every time correctly.
Especially when you get to these complicated ones where it's like the one that we thought was a quadratic, but really they can just solve for A, and this one here, when they're given the conversion factor for Celsius to Fahrenheit, they have to be able to combine like terms, distribute and combine like terms properly.
Yeah, I think, right, no, that makes sense. And this is actually, I think we're pretty aligned here, so the work today, we're not doing any properties, we're just doing variables on both sides without properties. Mastery in first hour was over 75%, because I've graded as they were going, and it's like, man, we are getting the process, and so I think tomorrow when we do the properties, they're gonna like be able to put it together better.
I say hold on the properties for now. We have a lot of flex time in this unit. Let's make sure they get solving the equations right first.
So today, if
they need to be able to solve.
today when they go through, if they're able to solve these, like if mastery is near 75% like it was first hour, do we still want to do no properties on Thursday?
Good ticket.
I would use the exemplar just because it's pulls up easier. You don't download it. It's on page 3.
Takes a minute to. These don't have a decimal or a fraction. This one does. I think on Thursday it's probably okay to bring in the justification again, but tomorrow we have to make sure that they know how to solve.
I keep thinking today is Wednesday. I'm sorry.
No, today's Tuesday. I think it's okay for Thursday, but for tomorrow, which is Wednesday, we have to make sure they can solve equations in which there's a decimal involved, there's a fraction involved, and we're gonna have to do some Minder arithmetic.
So
I said Minder algebra, should be Minder arithmetic.
in algebra.
Yeah, but
So then would you do a responsive day tomorrow to be like, we're gonna solve equations flawlessly, like,
yes.
and just add that day and shift things back a day?
No, I would change tomorrow. I mean, I think like don't make like using the properties lesson you have in there now. Save that in case if we have mastery 80%, then we can revisit it and have them justify. But because they don't actually have to justify on their test, just kind of put that to the side. But I think you can use the same problems you have tomorrow. That makes sense. So
yeah, no, I
for tomorrow
totally
you have
understand
kiddos
you.
doing this one with the fraction and you have them justifying.
Right.
So I'm saying just don't scrap this because eventually or maybe next year we can work with like the different properties and things like that. So the way you're teaching them how to justify makes sense here. But that's not what they need tomorrow. What I'm thinking you should do is model a problem that involves a decimal and a negative. Have them try it in a round, and then model this problem right here, and then have them try around, just like you have it right here. You're just not doing this part tomorrow.
Okay. Okay.
Can you roll that back to me because I was unclear? What are we doing tomorrow?
The same thing with other properties.
Yes.
And modeling with a decimal and a negative.
Beforehand.
Right.
Yeah. Okay. And I made a problem for you here. So the vision is you model this little problem. You give them a try it. You take some laps. Then you model this one with a fraction. You haven't tried it, take some laps, IP. And on exit ticket, we'll just check to see if they can do it with a decimal, we'll check to see if they can do it with a fraction.
Yeah, that makes sense.
We can't move on to justification unless they can just very basically solve it.
So what I'm thinking tomorrow, and push my thinking here, there are students who are mastering this and really getting the properties. With those students, is it an okay extension to say like, hey, you got this right, like during my lab, you got this right, can you go back and name all the properties?
If you finish early, go back and name the properties.
Right, like
That's
I've got
fine.
2 minutes with kids still
I think
struggling.
that's fine,
Kanisha, go back and try and name all the properties as you go.
that's fine, yep,
Okay.
totally fine.
Okay.
Totally fine. So here's the revisions to make for tomorrow. The first is, I didn't make one for them to try. So first new first model problem, new first try it. You can add in a problem, let's say -3.2 equals,
I can write it, don't worry.
okay,
I'm with you on the keeping the negatives.
3.5 times 3 minus 2x, no, it's gotta be 4. Something like have them in beforehand. And then for the exit ticket, add in number 2, but without. Why am I doing something now? Add in number 2 just to solve. Add in number 2 for
Oh, from the
Monday.
exit ticket, the
Mhm.
same question.
Mm-hmm. Just to solve it.
Okay. Will you pull up that exit ticket for tomorrow?
I have it right.
Or this one, I guess this one today. Oh. Okay.
So keep this one
What was the reason we had the
and
fractions?
then add the decimal. Oh, because the fractions, there's
It's
a
on the
decimal and a
test.
fraction are both on there. That's why we have to win at this.
The
'Cause there's
decimal
so many
is much
instances.
easier to work with than the fractions.
Right, but I think that you have to win at the decimals first. That's why first you should model this, do some laps.
Sure.
If they're not doing it.
So tomorrow's exit ticket, you would do this number 2 first, then the fraction one? Okay. I'm getting hair everywhere, so I'm pulling my hair, sorry.
That's what I could do, it's okay.
Okay. Cool.
Do you wanna take a minute to revise your stuff, so it's done? You do that, and I'm gonna talk to you about what you're gonna monitor for in your rounds. Can I take a look?
Yeah.
Model problem.
Freeze.
Microsoft Word just has so many bugs. Anytime I'm trying to do anything at Word, it does this, especially when I try to print.
Hopefully it saved all those changes. So we have new X ticket,
Same problem, perfect.
we have new model, new try it, new model, same model, same
Wait, can you
try
go
it.
back up? I'm sorry. This is one we, cool.
It's time to leave.
And for kiddos who finish early, I think, or who have shown mastery, like Acacia's and that, we can go back and say, justify. Great. What to monitor for, let's annotate that. So the first thing we gotta look for is, and then try it after you do the decimals, what's your first lap?
I'm gonna look for distribution and combining like terms
I would say
correctly.
just combining like terms.
We had to distribute first, right?
That wasn't a gap though. They actually did do that well. In first lap, I'm gonna check to see that you've combined like terms properly after you've distributed.
Okay.
Or you can say, acknowledge their expertise. I know we know how to distribute, so I'm gonna come to check to see that you could combine like terms correctly after you did that.
Sure.
And then the next
The
lap,
next,
if you have time.
or
That's the
if you-
highest leverage thing you gotta check. But if you do that, would be,
using inverse operations correctly.
and the more times you can say inverse means opposite, the better. I think like this is something we've learned in Dr. Jones' class too. Kids just don't know what the word inverse means.
Mm-hmm.
So just inverse, opposite. Great. All right, same thing, model 2. And they're try it. You're gonna come around and check for combining like terms. Like I know you know how to distribute. I'm gonna check that after that you've combined like terms correctly.
I think it's still important here for me to like really aggressively monitor them getting the variable on one side too, because they're gonna be adding.
Yes,
And
but I really
subtracting
don't think that
variables.
was the hugest gap here. They all tried to do that. They all were working stuff over.
But there wasn't variables on both sides on this one, and like just from previous experience, that's a place where kids like will try to combine like terms when they shouldn't.
Because the second one's a little more complex because it involves a fraction and variables on both terms,
Mhm.
both sides. Okay. Alright. I want to do something with the bubble kids. I'd like to see their work from this. I don't want you to have to be compiling this. I think this is something that Josh can do. Is pull these bubble kids because I want to see like their work from how they did tomorrow.
Are all of these bubble kids?
Yeah, so what I'm gonna do is I'm gonna type up their names. Type up their names and pop them into a folder, and then you can have Josh pull their work at the end of the day. That's
Cool. I can pull them from today too, because they are just there's like solving and combining.
I
like
wanna
terms
see how they do
today.
on the exact same problem.
Okay.
I'm curious. So I'm really gonna be zooming in on that number 1. Oh, I forgot I have this on.